Check, 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 mic check. Are we live? Are we good to go? Yeah. Okay, it doesn't say so, but I am pretty sure we are good to go. Check, check, mic check. Is the audio good? Yeah. Okay. All right. It seems like we are live. I'm gonna drop a few texts. Hi, Atharva. Hi. Hi, Suraj. What's up? All right. It seems like we are live. I think we can move forward. No, 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 no. I don't think so. I think Suraj was here, but like he just didn't text. Maybe I don't know. So yeah. Okay, not the usual place that we used to record, but it should be fine, right? There are a few articles that we're gonna, you know, obviously go through today. The main one is the OpenAI O1. We'll be talking about that model today. We'll be also talking about a blog post, which is kind of my favorite. It's gonna be very low key today, but let's see what we can gather, right? Fair enough. All right. It doesn't seem like we're gonna have much audience today, but yeah, that's completely fine. We have missed two lives in a row because of some other prior commitments from my side, but hey, whatever. We're gonna try to make up for that. All right. So before 2 days, there was an announcement. The announcement was OpenAI has released a new model which is called OpenAI O1. That's the model, right? That's just what they released, right? So let's just go through the entire article. Let's just try to go through it and understand what exactly is it that it does, right? All right. So uh, at the moment, currently, you guys should know, OpenAI has four different models, kind of, right? So let's just go to the product section, and if we and just go to the for everyone section. Can it show us how many models does it have right now? Let's just let's just go through pricing plans. Come on, really? They are not gonna show me the list of models. All right, so we have GPT 3.5 Turbo. That's just one of the models that we just have at the moment, right? Uh, other mom, God, where is it? Yeah, we just have to go through the API documentation. I feel like this smart. Do I have to actually really? Can it not just? I think we can just go to chatgpt.com and try not to leak stuff. All right, okay. So it doesn't technically show us what model it has at the moment, right? But at the moment, if I have to just, make a list or something, we have GPT-4o, okay? So if I just go to excalibur.com and, delete everything. So at the moment, we have, if I could type GPT GPT 4. All right, then we had GPT 4o. Okay, that's an O. And then we also were introduced with GPT 4o, okay, mini. But now we have something known as GPT O1. All right, so these are the current models that ChatGPT provides. Now, usually what happens is by default, you get access to GPT-4o. If you run out of, I don't know, prompts or something, then you are now defaulted to GPT-4o mini. But they have introduced this new model, which is GPT O1, and there's also GPT O1 mini. All right, so these are the different models that we have at the moment. Now we won't be getting access to O1 or O1 mini because I don't have the upgraded version at the moment, and that is completely fine. But if we just go through what they have actually introduced, so let's just go through that. So we have developed a new series of AI models designed to spend more time thinking before they respond. All right. They can reason through complex tasks and solve harder problems than previous models in science, coding, and math. Today we are releasing the first of this series in ChatGPT and our AI. This is a preview. So basically it's a preview model. It's not a final model, but yeah. So basically what they have done is that they have taken their model. So they have taken their GPT model and they have told it to specifically take more time to think. You know how you usually ask a question to ChatGPT and then you get an answer like very quickly, which is what we call it inference time. What they are doing here specifically is that the model will spend more and more time just to figure out what the answer is supposed to be, right? So, for example, if I go to ChatGPT right now, right, and if I ask the question like a very simple question, in fact, we should actually use the new app that we have. Let's just open that app, Misty, and let's just try to ask a very simple question to a lot of different AI bots. So let's ask Llama 3.1. All right, and the question is very simple. How many R's are there in the word strawberry? All right, so we'll take this entire prompt and then let's just create a new split chat and let's put this aside for a second. So we'll ask that to Llama 3.1. We'll also ask that to, let's say, Gemma. Sure, let's just ask that to Gemma and let's just see what is the answer that they are giving. All right. Okay. So for some reason, Llama just says that, hey, there is one R in the word strawberry. And Gemma says that, hey, there are two R's in the word strawberry, which once again is not true. Right. So I'll just write, that is not true. Can you recheck? Okay. Once again, they LLM models, they can like code very well and they can do a lot of stuff, but they get stumped on like these simple questions. So you can see, oh yeah, there are two words, two R's in the word strawberry, and here up Gemma actually got it like like there are three R's in the word strawberry. But you can see that these language models are not that smart. Like in reality, they are not that smart. Even if I, for example, take Claude, so if I just open up a new chat over here, and let's say we use the, oh, I wouldn't have the Claude model, do I? Oh no, I think it's on my other computer. But regardless, the point is, they are not that smart, right? Whereas the new model that OpenAI has released, it's a model that actually thinks it through, and they are claiming that the model performs similar to PhD students. So imagine there's a student in masters, and it's on that level. It's on a level of like a PhD student. All right, be it in physics, chemistry, biology. It also does really great math and coding, and in a qualifying exam for International Maths Olympiad. Once again, mathematics Olympiad, that's a very big deal. That's a very difficult type of test. But GPT-4 correctly solved only 13% of the problems, which was the previous model, while the reasoning model scored 83%. Once again, that's actually a very big deal, right? So if we actually scroll down, we can actually see a few videos. So let's just go through the videos in a while. All right. And let's just go through this specific part, right? So I'm gonna turn off the audio, but let's just see. Come on. Do you mind playing? Maybe if we reduce the quality. Yeah, I am pretty sure you guys can't hear the audio because I'm not sharing the audio right now. But maybe I can do that. I can do that. All right, so I'm just gonna, actually mention what they're doing. So this person has now, just gave a prompt. What is wrong with this? Yeah. So this person has just given a very basic prompt that hey, you have to create this game. And now you can notice that it's taking a lot of time coming up with the solution. Like it's actually spending a lot of time instead of, just giving the code, it's actually trying to figure out what is happening back and forth. And so, yeah, that's what this model is about. That's it. So it thought for 21 seconds and now it's, telling you the process that, hey, it thought about the game, then it organized the code, then it gave the solution, etc., 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 and so on and so forth. Right. So that's what happened. That's basically it. Yeah, that's the model. All right. That's what I wanted you guys to know, that there's a new model in the town. All right. Yeah. So he's going to paste it in Sublime Text and then he's going to run. And yeah, that he created a game successfully. Uh, there's not much to it, sadly. Right. Anyways, so that was one part of the story. The another part is the blog post. Anyways, if anyone has any questions on that, please let me know, because I think it's like pretty trivial stuff. Yeah. All right. Suraj gave a peace sign. I don't know what that means, but hey, you do you. All right. So let's go through the blog post. Okay. So this blog post is about this specific website, which is 1 million. So far, so good. Yeah. Okay. Fair enough. Okay, so this website once again is the blog post is talking about a website which is called 1millioncheckboxes.com. Okay, the website is not available anymore. But this basically is the entire story of what people were doing with this website. So to just decide the website, yeah, it had 1 million global checkbox on it. Checking a box checked it for everyone on the site immediately. So if I was on site and you were on site, and if I check one of the checkboxes, it would update it on everyone. Now that sounds very simple, right? It's because it is. The thing is, creating an infrastructure around that, creating a live update feed for everyone involved is actually pretty freaking complicated, right? So I'll be going through the journey of what actually happened. Now, just because there are 1 million checkboxes does not mean that the maximum number of checkboxes you will have, like on and off, it would be like 1 million. No, because someone can checkbox a specific thing multiple times. And so here, some like the total amount of checks was 6,500 million. Okay, that's 650 million different checks. Like once again, that's a very big amount, right? So let's just go through like this small video that they have. So this is how the website would look like, right? Everyone would check and everyone would uncheck and something like that. Obviously, there's a lot of good stuff to do. Like you can create patterns, you can actually create a bot which would go and like check everything and so on and so forth. But let's just go through the entire article, right? Yeah, so this person, they built a site in 2 days, right? He thought that he'd get a few hundred users max, but that is not what happened. Instead, within hours of launching, tens of thousands of users clicked millions of checkboxes, piled from Hacker News, r/internet is beautiful. Once again, that's a subreddit, Mastodon, and Twitter. A few days later, OMCB, or 1 million checkboxes, appeared in the Washington Post and the New York Times. Once again, let me tell you, this is just a dude, a student just like you guys, created this whole thing on his like personal laptop in like 2 days, and that's it, right? Here's what the activity looked like on the first day. He launched at 11:30 a.m. Eastern Standard Time. Okay. So he had unique visitors in like what, 20,000, right? By like 4 p.m. afternoon, he had 20,000 live uh, like visitors. He also had a lot of checkboxes, right? So he doesn't have logs for checkboxes for the first few hours because I originally only kept the latest 1 million logs for a given day. I wasn't prepared for this level of activity. The site crashed a lot, but by day two, I started to stabilize things and people checked over 150 million 50 million boxes. We passed 650 million before the sunset. Like before he actually ended the site, like after 2 weeks. So let's talk about how he kept the site online. All right. So the original architecture was very simple. So you have like someone, okay, let's just go through the whole thing. So imagine this is a server, all right, and someone is checking a specific box. Okay, someone is checking a specific box. The UI gets rendered later on, right? But it actually goes on the server, it actually check marks a specific thing, and then it will update all the other UIs. Okay. So let's just actually try to draw that on Excalibur. It's actually not that pretty complicated. So for example, imagine you are the client, all right, and let's say this is the server, and there are other clients all over the world, all right. So let's just draw a few boxes. Okay. Now you, let's just write it as you. You are here and you are sending a request to update some specific checkbox. Okay, let's say it was let's say you are ticking checkbox number what? Oh, come on, wouldn't it let me, let's say checkbox number 3. Okay, so let's say you are updating that checkbox. Once you send that update request, obviously the UI loads for you. Like it will just tell you that, hey, checkbox was checked. Once again, there's no data to be sent. Like it can happen just on client side. But what will happen is the server will update the code internally, and then it will actually update for everyone else, right? And that is what is happening. Once again, it's a very simple type of like kind of a website, not a big deal, right? Now, the issue happens when you have thousands of people clicking on millions of different checkboxes, right? And that is bound to happen. So everyone is sending a request, they get a request back immediately, and then everyone else has to update. Imagine what happens if two people check on the same text box. Like, imagine if they are checking on the same checkbox at the same time. How do you even understand like what came first, what came second? The amount of overhead the site would need, it's a lot, right? So yeah. Now, obviously, how do you even store the data? But before we move on, how do you guys think we can store the data? Like, do we store it in a variable somewhere? Like, hey, checkbox number 3 is updated. So, like, maybe there's like some sort of a variable. Do we do that? What do you guys think? Well, let me just create a very simple script. Does that work? I don't know. All right. Tell me, guys, what do you think is gonna happen? Do I create some sort of a variable? Which, yeah, sure. Access. Sure. Checkbox equals. Do I create some sort of an array, right? And maybe the array has like list of arrays. Like, hey, is it true or is it false? Or maybe I can do something like, for example, let's just do this. 1 comma true, and then maybe 2 comma false. And I keep on I keep on updating this value, so on and so forth, for like 1 million. So dot dot dot, and then we have like 1 million whatever, right? Do I do that? Is that the simplest way? What do you think, chat? Like, should I store the data like this? Or maybe another way to do that would be, for example, to store it in a tuple or maybe in a dictionary of sorts. So, for example, I can just say, hey, 1 is true. And then I can say, hey, 2 is false. Or 3 is, blah, 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 whatever, it's true again. And maybe I can update the data again and again the way people, keep on coming in. Do you think this is a smart idea? What do you guys think? Huh? Chat? Should I store the data like this? 1 million? Do you think a laptop can handle it? I mean, yeah, sure. 1 million isn't that much, right? So, for example, if I just write, let's say we go from 1 to, yeah, let's just go to 1 million. And if I tell, let's say, the computer that, hey, why don't you add for 1 million terms, right? 1 million. Is it supposed to be that big of a deal? I don't think so. Like, hey, it can calculate that. 1 million is fine, but just stick to 0 and 1. Okay, how would I stick to 0 and 1? That's a good option, right? You can just stick to 0 and 1. Now, what you are saying, Harsh, makes complete sense. But if you're talking in terms of Boolean values, well, true and false are technically 0 and 1 at the end, right? So what this person is doing, instead of storing it in a high level programming language in terms of like, variables and stuff, is actually going on a low level binary, and it's just 1 million bits. Like he is just using the actual bits as the information if a checkbox is ticked or not, instead of creating a whole variable and stuff. What he is doing is actually quite quite easy and quite logical is, let's say you have binary here, and let's say you have 1010 whatever, let's just not introduce two. So these number itself, like this one, it means okay, the first checkbox is one. Second one, okay, the second checkbox is false. The third one, it's like tick mark. So he's actually using binary, right? Now it might feel like, oh my god, like how many ones and zeros? Well, technically, 1 million ones and zeros, you would have to be like 1 million bits. But if you calculate 1 million bits, it's actually not that much, right? How do I know that? So for example, if I just write 1 million 0.125 megabyte. If I convert that to, let's say, kilobyte, it's like 125 kilobyte. That's nothing. 125 KB is nothing. That is how much the storage is the site is taking, right? 1 million bits. It's not much for a computer. It's not much. So we don't need to actually go through like variables and stuff. We can just use this, right? So clients store the bits in a bit set. Okay, it's an array of byte that makes it easy to store, access, and flip raw data. We are not going to talk about bitset right now, but that should be fine. And we reference that bitset whenever we are rendering the checkboxes. Clients tell the server when they check a box, the server flips the relevant bit and broadcasts that fact to all the connected clients. Okay, simple, fair enough, everyone. Now, to avoid throwing a million elements in a DOM, clients only render the checkboxes in view, plus a small buffer using a React window. Now, a React window, once again, it's kind of an npm package. All the package does is, instead of showing you everything, like there are 1 million checkboxes, instead of rendering 1 million elements, it just only highlights whatever is on your screen, right? So like top end to like bottom end, just only highlight whatever is available on the screen, maybe like a few thousand, and then some buffer at the bottom, right? So whenever you scroll, it will keep on like rendering new stuff, but it won't render the whole 1 million, because if it did that, your browser is going to crash. So yeah. Now, obviously, this person could have done that with a single process. He wanted an architecture that he could scale. And then X used to use Redis for the first time. Redis, once again, that's a kind of a database thingy. Not gonna go there. So the actual server setup looked like this. Okay, so you have Nginx running, which is kind of a reverse proxy for like static content. Then you have Flask servers, which runs on kind of Python. And that is what is talking to Redis, which is kind of a database where the whole thing is stored. Okay, so clients hit Nginx for static content and then make a GET request for the bitset state and a WebSocket connection for updates. So when you are connecting to the server, it's not just a HTTP GET request and then a return like back or whatever. That's not what is happening. In fact, you have a constant connection which is maintained using web sockets. Okay, that's what is happening. So if you would open this in Burp Suite, you send a request, you get a request back, and then you will continuously be sending back and forth requests using web sockets, because you have to update, right, every single time. So that's what WebSocket does. You have a constant connection, kind of. Anyway, the state is stored in a Redis, which has good primitives for like flipping individual bits. Clients tell Flask when they check a box. Flask update the bits in Redis and writes an event to a pub sub, which is just a message queue. Both Flask servers read from that pub sub and notify connected clients when checkboxes are checked or unchecked. Okay, so let's just go through this specific diagram, which is client A. So, for example, client A, person A, whatever, that person is checking box number 2, which will go to Flask. Flask will, first of all, Flask, once again, is the Python Flask. It's just how you create web pages, uh, which will log it. It will flip the bit set, and then it will write that data to the pub sub, like it will be in a queue. Then Redis will actually read that from the pub sub. It will go to Flask, and then Flask will tell all the other clients, in this case, client B, 3, C, whatever, that hey, box number 2 is checked. Okay, so we need the pub sub because we got two Flask instances. Flask instance can just broadcast box 2 was checked on it to its own clients. Finally, the Flask servers do simple rate limiting on request per session, new session per IP, and regularly send full state snapshots to connected clients in a case a client has missed an update, because let's say that a tab was in background. So it is sending updates like, hey, this box was checked, this was checked, all of that is good stuff, right? But imagine, let's say your tab is in the background and let's say it's not updating quite frequently. And then you would open that tab and now you're still getting updates that, hey, checkbox number 1000 was checked, 1001 was checked. but you were offline from like 500 to like 800. So what happens? So we are also constantly sending like a full update, like a full stack of information that, hey, listen, all of this is like the current situation, right? So you are sending updates every few seconds, for example, and then every minute you are sending the whole data that, hey, listen, in case you missed the last 50, this is the whole data. Like, hey, these many checkboxes are like, implemented or not. Once again, it's like 125 kilobytes. It's not much, right? All right. So there's a kind of, yeah, I'm not going to go through the code, but that's the Flask side. The code isn't great. It's not even async. I haven't shipped it to production like 8 years, blah, 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 blah. But whatever. Now, principles for scaling. Okay. Bound my cost. I need to be able to math an upper bound on cost. I aimed to let things break when they broke my expectations instead of going serverless and scaling into bankruptcy, which is once again a pretty good standard to have. That, hey, listen, if the site keeps on increasing, I will let it die because I don't want to like go bankrupt. Okay. The costs can actually go to millions if someone figures out like some sort of a DDoS attack. So it's completely fine. Embrace the short term. I assume the site's propriety was fleeting. I took on a technical depth and aim for okay solutions that I could hack out in hours, or great solutions that would take me days or week. Once again, it's type of I keep on mentioning like there are two types of programmers, right? One is the type of programmer who would actually hack together some solution in like a very short time, but it's not good for long term. And then there's the second type of programmer who actually thinks everything, and they might take time to actually write code, but their code is much more stable over long term. And you need both type of programmers, and you should be both type of programmers, right? Anyway, so you use simple self-hosted tech. So I am used to running my own servers. I like to log into boxes and run commands. I try to only add dependencies that I could run and debug on my own. Have fun. I optimized for fun, not money. Scaling the site was way fun. So was saying no to advertisers. Keeping it global. That's it. The point is this person does not want to, like earn money, does not want to put ads and stuff. And that's basically it, right? So day one, once again, we'll be going through day by day. There's like once again a lot of stuff, but I feel like we'll go through day one, and then we'll see if the time permits. We'll just go through it. uh Hopefully everyone is fine with that. Hopefully you're having fun with the article. Otherwise, we'll cut it short. I don't know, we can talk about other stuff, but I find this genuinely interesting. Let me know in the chat. Okay, so within 30 minutes of launch, the activity looked like this. Okay, so we have already seen this video. People are checking and checking, stuff that is happening. Yeah, fun stuff. The site was up, but I knew it wouldn't tolerate the load much longer. The most obvious improvement was more servers. Fortunately, this was easy. Nginx could easily reverse proxy to Flask instances on another VM, and my state was already in Redis. I started spinning up more boxes. Now, obviously, the obvious solution is just increase servers. Like instead of optimizing anything, just put in more hardware, and that usually solves it. So yeah, that's what he did. So he started a second server, and it immediately hit 100%. I originally assumed another server or two would be sufficient. Instead, traffic grew as I scaled. I hit number one on Hacker News, which activity on my tweet skyrocketed. So he started looking for bigger optimizations. My Flash servers were struggling. Redis was running out of connections. Did you notice I wasn't using a connection pool? My best idea was to batch updates. I hacked something in that looked like this. Once again, I'm not gonna go through the code. I did bother with backwards compatibility. I figured folks were used to site breaking and would just refresh. Okay, this is kind of important. So if you have a website and if it's like constant, sending back and forth like web sockets and stuff, and if you make an update, if you change something on the site live, and if you don't have backwards compatibility, it's not gonna work. Like the site would break, it would stop updating. You would have to refresh the site, right? So yeah, that is something that you should consider. Like if you're ever building a solution of something like this is something to consider. That if you are making live websites, things will break every now and then. All right. Anyways, so yeah, he also added a connection pool. This definitely did not play nice with the G Unicorn and Flask, but it seemed to reduce the number of connections to Redis. All right. I also beefed up my Redix box. Easy to do since I was using DigitalOcean's managed Redix from a tiny one shared CPU. Once again, that's one shared CPU. That's like nothing. instance to a box with 4 dedicated CPUs and 32 gigs of RAM. I did this after Redis mysteriously went down. The resizing took about 30 minutes. The server came back up, and then things got trickier. All right. It was not a good night to have plans. At around 4:30 p.m., I accepted it. I had plans. I had spent June at a camp in ITP, a school at NYU, and the night of the 26th was our final show. I had signed up for display a face-controlled Pac-Man game and invited some friends. I had to go. I brought an iPad and put OCMB on it. I spun up the servers while my friend Yuri and my girlfriend Emma kindly stepped in to explain what I was doing to strangers when they came to my booth. This dude is coding on an iPad. Damn. I had no automation for spinning up servers, so my naming conventions involved as I worked. So, oh yeah, he just kept on like calling the servers second backup, prod, 3, 4, 5, 6. Yep. Okay. I got home from the show around midnight. I was tired, but there was still more work to do. Okay, guys, this is what dedication feels like. All right. There's always that one project where you are so tired but you still want to get that project done. Hopefully you guys have like had that feeling. You know what I'm talking about. Reducing the number of flash processes on each box. I originally had more workers than the number of cores on a box. This did not work well. Increasing the batch size of my updates. I found that doubling the batch size substantially reduced the load. I tried doubling again. This appeared to help even more. I don't know how to pick a principal number here. All right. So it's just increasing like the batch size, like how many updates do you send in a while? But hey, whatever. I pushed the updates. I was feeling good, and then I got a text from my friend Greg, technology. I'm so proud. Are you gonna get hit with a server bill for bandwidth, or is the bandwidth not cray cray? The thing is, this person wasn't thinking about bandwidth. He was only thinking about CPU and like RAM and if the server has enough space or all of that stuff. But when you have a server and we are doing a lot of back and forth, the bandwidth is gonna be horrible, right? Like you have to understand that. So I realized I hadn't thought hard enough about bandwidth. DigitalOcean's bandwidth pricing is pretty sane, which is $0.01 per GB. Like that's 1 rupee per GB. Once again, it's not that much, right? But if you think about it, if there are millions of people coming to your website back and forth, the GB, like it's gonna be in terabytes. Like the bandwidth is gonna be in terabytes, and you are now paying like a lot of money. Let's just go through the calculation very soon. So after a pretty generous per server compounding fee allowance, I had a TB of free bandwidth from past work, and pre-launch I didn't even think OMCB would make a dent. I did back of the envelope math. I sent state snapshots, which is 1 million bits, 1 megabyte. Okay. Once again, because we have to think, it's not just people visiting the sites, it's also the update. So if one person checks a simple checkbox, that update goes to like 20,000 people live. Okay. And not just that, he's also sending updates every hour or every minute of the whole thing, right? He's sending an entire snapshot. Like he's not just updating a single checkbox, he's sending the entire snapshot to however many people who are live. One snapshot costs around 125 kilobytes. He's sending it in, let's say, for example, batches of like 16 or 10 or 12 or whatever. That's somewhere around 1 MB, right? So he's mentioning that he's sending 1 million bits, which is around 1 megabit or 128 kilobytes every 30 seconds. With 1,000 clients that are already here right now, that's 2 GB a minute or 120 GB an hour. And we are probably going to have more clients than that. And we haven't even started to think about updates, right? Updates are different. This is just batch processing. It was 2 a.m. I was very tired. I did some bad math. Maybe I confused GB an hour with GB a minute and freaked out. I thought I was already on the hook for thousands of dollars. Once again, a lot of stuff. So I kind of did a lot of things. Frantically texted Greg, who helped me realize that my math was way off. Ran this command to show my Nginx box to see how many bytes I had sent, confirming that my math was way off. Started thinking about how to reduce bandwidth and how to cap my costs. Immediately reduce the frequency of my state snapshots, and then with the help from Greg, pared down the size of incremental updates I send to clients. So you have to reduce the snapshots. You can't be sending the whole website to everyone again and again and again for like 20,000 people. You can't do that every half a minute, right? So yeah, he just like updated the stuff. I moved from stuffing a bunch of dictionaries into a list to sending two arrays of indices with true and false implied. This was 5 times shorter than my original implementation. Okay, so 5 times of difference. That's a lot. And then I used Linux's TC utility to slam a hard cap on the amount of data I could send per second. TC is famously hard to use, so I wrote my own configuration script with Claude's help. Hey, Anthropic, Claude mentioned. This just limits to traffic flowing over, the Ethernet, which is your public interface, to 250 megabit a second. That's a lot of bandwidth, which is around 2 GB per minute, or just under 3 terabytes a day. But but it let me reason about my cost, and at this much amount, I knew I wouldn't go bankrupt overnight. Once again, this is just first day, guys. Imagine making a website and then at like 3:30 a.m. in your bed, you're thinking about this. Thought I was lucky to add limits when I did. I now realize someone probably saw my tweet about reducing bandwidth and tried to give me a huge bill. How? Let's just see. Blue is traffic from my workers to Nginx. Purple is Nginx out of the world. The timing is suspicious. This person just mentioned it online on Twitter that, hey, I'm going to reduce my bandwidth. Someone figured out a way to cheat the system somehow. So, yeah, I woke up a few hours later. The site was down. I hadn't been validating input properly. The site didn't prevent folks from checking boxes above 1 million. Someone had checked boxes in the 100 million range. This let them push the count of checkboxes to 1 million, tricking the site into thinking things were over. Redis had also added millions of zeros between 1 million bit and 100 million, which 100x the amount of data that I was sending to clients. This was embarrassing. I'm new to building for the web, but like, I know you should validate your inputs, but it was a quick fix. I stopped Nginx, copied the first 1 million bits of my old bit set to a new truncated bit set. I wanted to keep the old one for debugging. Taught my code to reference the new bit set and added proper validation. Once again, you can just like you use like burp suit and stuff to like check, and that's what people did. Not too bad. I brought the site back up, adding a replica and port scanning on my VPS. The site was slow, the number of checkboxes per hour quickly exceeded the day one peak. The biggest problem was the initial page load. This made sense. We had to hit Redis, which was under a lot of load, and we were making too many connections. Due to it, the bugs in your connection, pooling and stuff, right? I was tired and didn't feel equipped to debug my connection pool issues, so I embraced the short term and spun up Redis replica to take load off the primary and spread my connections out. But there was a problem. After spinning up the replica, I couldn't find its private IP, which is weird. To connect to my primary, I used a DNS record. There were records for its public and private IPs. DigitalOcean told me to prepend replica and then hyphen to those records to get my replica IP. This worked for public one, but it did not exist for the private DNS record. And I really wanted the private IP. I thought sending traffic to a public IP would risk traversing the public internet, which would mean being billed for way more bandwidth. Once again, see, you guys have to understand when there's like a server, like there's an actual server farm, and if let's say you have two devices on the server farm itself, you have private IP address. So imagine like they are actually next to each other and they are in the same Wi-Fi and they can talk to each other. Now, obviously, you can send data through the public internet and back to this specific box, but now you are also doing in and out bandwidth. You are facing ingress and egress like costing and stuff. It's a lot, so it's easier if you do it using the private IP. You got my threads notification. What notification? I have no idea what you're talking about, but hey, good for you, Atharva. Anyways, so I couldn't have figure out how to find replica's private IP in an official way. I'm sure you can tell me how. I took a different approach and started making connections to private IPs close to the IPs of my Redis primary and my other servers. This worked on the third or fourth try. Then I hard coded that IP as my replica IP. Once again, so you have an IP address, you are now searching kind of around the IP address to actually figure out what's like the IP address for like the other box which is connected. Like that's an option, sure. Yeah, so stabilizing. My Flask processes kept crashing, requiring me to babysit the site. The crashes seem to be seem to be from running out of Redis connections. I'm wincing as I type this now, but I still didn't want to debug what was going on there. It was late and the problem was fuzzy. So I wrote a script that looked at the number of running Flask processes and bounced my system D unit if too many were down. I threw that into the con tab on my boxes and updated my Nginx config to briefly take servers out of rotation if they were down. This appeared to work pretty well. The site was stabilized. Stale updates. At around 12:30 a.m., I posted some stats on Twitter and got ready to go to bed. And then a user reported an issue. So yeah, this person is like, I think replicas make the total check strange. It's 800K, then 300K. At this moment, it's 100K plus. And I saw just a few K briefly. Struggling. Yeah. So something is happening. Okay. There was a classic bug. To keep client checkboxes stayed synchronized, I did two things. Send clients incremental updates when checkboxes were checked or unchecked. So yeah, this is the two types of checkboxes I was talking about. I'm sending incremental updates every second someone checks a checkbox, and then I'm sending a full state snapshot in case they missed an update, right? So he's doing both of those things. The thing is, these updates didn't have timestamps. A client could receive a full state snapshot and then apply an old incremental update, resulting in them having a totally wrong view of the world until the next full state snapshot. I was embarrassed by this. I have written a whole lot of state machine code and know better. It was almost 1 a.m. and I had barely slept the night before. It was a struggle to write code that I ironically thought I could write in my sleep. But timestamped each full state, timestamped each update, and then added the max timestamp to each incremental update in batches I sent to clients. Taught clients to drop the update batches if their timestamp was behind the timestamp of the last state snapshot. This isn't perfect, but clients can apply a batch of mostly stale updates as long as one update is new, but it's substantially better, right? Once again, this person is trying to code. He's texting to Claude that, hey, what are we trying to do? So I don't think we should add that line, but I'm really not sure. Think carefully. I'm very tired, but if we get a late stage snapshot, I feel like maybe we want to apply it. Like this dude is texting an LLM at like 1 a.m. trying to fix a bug. I think that's just awesome. I ran my changes by Claude before shipping to prod. Claude's suggestions weren't actually super helpful, but talking through why they were wrong gave me more confidence. So yeah. Anyway, there's an entire section about rewriting the whole thing in Go. I'm not gonna go through that, right? Uh, it's a whole thing about like he's writing everything in Go, and I'm not gonna read through all of that. So I'm gonna go through what I learned this part, and then we're gonna end the live. It's already very close to like 11. So, well, a lot. This was the second time that I'll drop the link to this article in the chat. You guys can read it yourself later on. Second time that I put a server with real backend on the public internet, and the last one barely counted. Learning in high intensity but low stakes environment is great. Building the site in 2 days with little regard for scale was a good choice. It's so hard to know what will do well on the internet. Nobody I explained the site to seemed that excited about it. And I doubt I would have launched at all if I spent weeks thinking about scale. Having a bunch of eyes on the site energized me to keep it up and help me focus on what mattered. I'm happy with the tech that I use. Redis and Nginx are incredible. Running things myself made debugging and fixing things so much easier. It was a little painful to not have full control of my Redis instance. The site cost me something like $850 to run. Donations came pretty close to that, so I'm not in the hole for that much. Once again, spending $850 to like what create a site like this is like what, 71,000 rupees. Okay, that's a lot. I can never do that. I'm just saying that I can never comfortably spend 71,000 rupees to run a little experiment like that. Yeah, I mean, he mentions he got donations and stuff, so like that's fine. But like, hey, that's an iPhone right there. Let's, we wouldn't mess up with that. In the future, I might spend some time trying to decode the pricing pages for convents or durable objects, but I'm proud of scaling it on my own terms. I think it's worth noting that things worked out okay. This also validated my belief that people are hungry for constrained, anonymous interactions with strangers. I love building sites like this, and I was gonna build more regardless. But I'm more confident than ever that it's a good idea. Wrapping up, I've got one more story to tell about the site. It's about teen doing cool things. This blog is too long to tell right now. So once again, we'll do that in the next live. In the meantime, build more stupid websites. The internet can still be fun, right? That's it. That's the whole wrap up, right? Uh, I think this is fun. I think the story was really fun. Uh, like check boxes and stuff. 1 million check boxes once again, kind of a big deal. Um, but hey, people create stuff. This is fun stuff. Even though he spent like $850 on this, he got to learn a lot of things. I can guarantee you he must have learned more about servers and like you know Redis, like the database and stuff, than he would have learned at an actual university. you know so hey, something that I would tell you guys: create your own stuff like this. Like maybe create some sort of a solution, some sort of, I don't know, create some application, create some websites, create something cool, like cool shit. And maybe you'll learn about more about that technology than you would ever do in college. So yeah, create your own seam, create your own endpoint, create your own security solution, create your own antivirus. I don't know, do that. Maybe you will get to learn so much about cybersecurity. Maybe you will get to learn so much more about everything else, right? Yeah, that's it for this live. If anyone has ChatGPT subscription, if they are willing to lend it to me for like a few days so I can test out the O1 model, let me know. Otherwise, it's completely fine. All right, that's it for this live. I am not at my usual pace. I'm not at my desk. I am actually, uh, well, I'm on a holiday again for the Saturday and Sunday, so it's not the usual live, but we'll be going back to normal stuff later on. Join our WhatsApp community if you have any questions or stuff. If you have any interesting things to share, you can join our WhatsApp community. The link should be in the description. There's a new video on the channel which is talking about RAG and how to actually use like these LLMs to actually study and like to talk to PPTs and to use like YouTube videos and like interact with YouTube videos. You can check that out as well. So yeah, that's it. Have fun and stay curious, and good night.